Hello, my name is Logan Washburn, and today I'll be explaining how to build an ACLED array. It is an array of LEDs that is powered off of AC voltage. Now, to start off, we need to understand the difference between DC voltage and AC voltage. Okay. DC voltage, which is what you usually get off of batteries, AA, D cell batteries, it is constant. So here's time and here's voltage. Let's say you have a 9-volt battery. It's constant over time. Now AC voltage, usually a cosine wave. It's sinusoidal. It could be sine or cosine, but for this respect we're going to do cosine, so let's do that. So this is one period, and let's say it's 120 volts, usually which comes out of your wall. Half the time it is positive 120 volts. And the other half the time it's negative 120 volts, the max. So a problem arises. It's not constant. So when we power an LED array normally, let's draw a source. Let's just draw one LED. We're probably going to have a resistor in there. Okay. Half the time it's going to be positive, half the time it's going to be negative. LEDs have a polarity, a positive side, a negative side. Positive voltage comes in, the negative side's to ground. So, with this, when we have positive 120 volts, depending on the LED, how it's rated, it'll light up. But once it gets to here, there's 0 volts and then negative volts, so it won't light up. It'll just be blank. And now, depending on the frequency of our source, which normally is around 60 hertz, one period will be 1 over frequency, which is roughly, I think it was 13 milliseconds, something around there, 13 or 16, let's say 16 milliseconds. Then that means that half the time, 8 milliseconds, it'll be on, half the time will be off. So it's going to flash. It won't be totally noticeable at 60 hertz, but you'll be able to notice it, but it won't be extremely apparent. However, it's very inefficient because half the time it's on, half the time it's off. And normally you would say, well, that's okay. If you can still see it and it still works, then that's fine. We're not using all the power. But in this case, we are. We're using 120 volts the whole time. It's just now we're wasting half of it. So, for our ACLED array, we are going to build a bridge rectifier. Okay, to solve our problem of it being on half the time and off half the time, we're going to build a bridge rectifier. Now, what this does is changes an AC voltage into a dirty DC voltage. Now, a clean DC voltage is what we described earlier as it changes with time. It doesn't change with time. 9 volts, flat line, does not change. Now, a dirty DC voltage AC hooked up to a bridge rectifier creates a dirty DC voltage. Now, how this works is over time, the voltage will have small ripples in it. And this is due to the AC artifacts called harmonics. Because AC voltage is changing during time, but the bridge rectifier tries to, nullify that change and keep it positive always. So we will construct a bridge rectifier using 4 diodes. Now, an LED is a light emitting diode with a symbol of this. Those lines coming off of it signify light. Now, just a diode is Okay, so in order to build a bridge rectifier, we will hook it up to source. And this node right here has a diode coming off here. And there's a diode pointing this way. Now remember, diodes have a polarity. That diode's going that way, and this diode's going this way. Okay, sorry for my poor drawing, but I'm not skilled in that way. Okay, so the positive terminal of the source is coming here. The grounded negative terminal is going here, and the terminals we're getting, or the nodes we're getting power off of are here and here. So this is where we're going to draw our power, and this creates dirty DC voltage. So here in methods, though, we want to be perfect. We want to be as perfect as we can. So with that in mind, we don't want these ripples. We want as straight as a line as we can. Now, in order to combat these ripples, we are going to hook up a capacitor over these terminals right here. So, and what this does, okay, what a capacitor does is it charges up and then discharges, and charges up again and discharges when needed. So when these ripples occur right here, it's the, okay, so at this point, this high, this peak, the capacitor is fully charged. Now when this starts to dip, the capacitor is going to discharge and draw a line here, and so it's going to recharge up here, and then it's going to discharge here, recharge here, discharge here. So there might be a little bit of a ripple still, but it's going to be not as pronounced as it is here. Okay, so with all of that in mind, we now have been charged to build a 20 LED array based off of AC current or voltage. So let's start off with our source. We have to pull power from an AC source, so that's the sign for AC voltage. Now we want to have a clean of source as possible, so let's put in our bridge rectifier. These LED diodes right here. My proportions are bad, but that's okay. Okay, so we have our bridge rectifier. That's where we pull our voltage off of that. Now, again, we're going to have our capacitor for, we're not going to go too big. We're going to go 100 microfarads. And now we're going to put in our LEDs. Okay, so these LEDs have a forward voltage of 3.1 volts or 3.3. It's either or. I think 3.1. Okay, so that means that we need to supply each LED with 3.1 volts to light it up, and they have a max current of 30 milliamps. Okay, so our source gives us roughly, let's see. Let me get back to you on that. Okay, so like I was saying, the voltage, the DC voltage, the dirty DC with the capacitor. Normally with just the bridge rectifier, we're getting around 7 volts, but once we hook up the capacitor, we are getting roughly, let's see if I can do this with one hand. 1 second. Okay, can you guys see that? We're getting roughly 18.5 volts. Yeah, you guys can see that. Okay, so that's what we have to work with. Now, when we are plugging up our LED array, like I was saying, we can only have so much going into one LED at a time. We can have 3.1 volts, which I lost that page. That's okay. 3.1 volts. Okay, so we have 20 of them, so let's see if we can put them all into 5 in series and with the 4 sets of them in parallel. So we have 1, 2, that's going to be a resistor, that's going to be a... Okay, so each LED needs 3.1 volts, and we have a supply of 18.5. So 18.5 volts, and each one draws 3.1 volts. So we have 1, 2, 3, 4, 5. So that's 3.1 times 5 is 15.5 volts. So we have enough. So now we need to use Ohm's law, V equals IR. So we have the max current is 30 milliamps. So the voltage is, I guess we'll use 15.5 equals 0.03 times R. We need to know how large of a resistor to limit the current going in. So this is all going to draw 15.5. So if we divide that, let's get a calculator out. Okay, so we have 15.5 divided by 0.03. It's going to give us 516 ohms. Now let's try it with, just to be safe, the 18.5 volts we're getting. So if we do 18.5, oh, mistake, 18.5 divided by 0.03, that's roughly 16, there's 616 ohms, and we'll use that just to be safe, because we don't know how much the LEDs are actually going to be pulling. If they can pull more than 3.1 volts, you know, we'll just see. So now they're in series, so we know that in series voltage is the same, so it's going to be pulling 18.5 volts over each, branch. So those are going to be the same. Those are going to be the same, and we'll do that one more. Well, here we go. So these LEDs in there. So they're each going to be pulling maximum of 0.03 amps. And so we're going to have roughly 616 ohms there. I've started backwards and put the LEDs on first, so it's a little easier to get the spacing right, and then I'm going to connect all the negative terminals of the LEDs all up to that node here, and then plug in all the resistors to these branches of the LEDs, and then put the capacitor in. I will be done. So, all right.
Here's a finished product of our circuit. It's in what was a former halogen light bulb container. It's hooked up to the transformer, connected to the leads. Our on-off switch is at the bottom, and as you can see, as you turn it on, the LEDs light up.
And that is the AC LED array. Thank you for watching.